Welcome to the second video about mean absolute deviation. Now that you know how to find the mean absolute deviation, we're going to learn how to interpret it. Before we get started, let's remember how to find that. Okay, so remember step one is to find the mean. Step two is to find the absolute deviations. And then step three is to find the MAD. So first we're going to add all of our values up. 8 plus 14 plus 27 plus 32 plus 40 plus 41. That gives me a total of 162, and I'm going to divide that by 6 because there are 6 numbers that I added together. And that gives me a mean of 27. Now I need to figure out the distance each number is from 27. So I'm going to make a list with all of my data values, and I'm just going to do 27 minus 8. That's 8 and 27 are 19 numbers away from each other. 27 minus 14 is 13. 27 minus 27 is 0, so there's that deviation. 32 and 27 are 5 numbers away from one another. 40 and 27 are 13 away. And that means 41 and 27 are 14 away. So now that I've found all of the deviations, I'm going to add those together to get a total. And then I will divide that by 6 to give me my mean absolute deviation. So 19 plus 13 plus 0 plus 5 plus 13 plus 14 is 64. And 64 divided by 6 is 10.6 repeating. And if you were to have to type this in and the course maybe said round to the nearest tenth, you would want to round that up to 7, because if there's another 6 behind it, that's going to round that up. Okay? So we're going to learn how to compare our MADs. Okay, so it says the following table shows a week's worth of high temperatures during the months of April and August for St. Louis, Missouri. Use the tables to complete the following. Part A, what is the MAD for each set? Part B, compare the MAD. Which set has a greater variability, meaning which one has a greater MAD, which data is more spread out. And then C, we're going to conclude. So on this screen, part A, what is the MAD for each data set? Okay, so remember to find the MAD, you first have to find the mean. Okay, and the mean is 72. Then you have to find the distance each number is from the mean. So 76 is 4 from the mean, 3, and so on and so forth. So all of the absolute deviations are here. We add them together, we divide by 7, and our MAD for April temperatures is 5.7. Okay, let's take a look at the MAD for August. So again, you're going to find the mean. Then you're going to find how far away each day is, or each temperature is from the mean, and average that together. So the average temperature for August was 89. Here are our absolute deviations, and you can see that the MAD for August was 2.6, which is less. Our next step is to compare. I want you to look up here. To compare sets, a higher mean absolute deviation indicates that the data points are more spread out from the mean. A lower mean absolute deviation, excuse me, indicates that they're clustered around the mean. So you can see here that the MAD for April was greater than the MAD for August. Okay, what can you conclude? Because the MAD for April is greater than the MAD for August, we can conclude that the temperatures are more spread out in April compared to those in August. The greater the MAD, the more the data is spread out. Okay, so the temperatures in August were much more consistent and close together day to day, where you see in April, we have 70s, 60s, 60s, 70s, and we even go up to the 80s. Okay, so go ahead and pause the video and try number 1. So this says data set 1 has a MAD of 5.3. Data set 2 has a MAD of 2.9. Well, we know that 5.3 is greater than 2.9. This is data set 1. This is data set 2. What can you conclude? The mean of data set 1 is greater than the mean of data set 2. We don't really necessarily know that. Okay, the mean could be smaller. It just could mean that the data values were more spread out. The median of data set 1 is greater than the median of data set 2. This has nothing to do with median. It doesn't tell us about the median. The values in data set 1 are more spread out than the values in data set 2, and this one is correct. Okay, because look right here. The higher the MAD, that means the more spread out the data points are. Okay, so make sure you know the higher the MAD, the more spread out your data is going to be. Okay, here's practice problem 2. You need to calculate the MAD and compare them for each data set. So I'm going to have machine A over here, machine B over here. So first thing, I'm going to find the mean of my data in the top part. So I'm going to be doing 4 plus 7 plus 3 plus 5 plus 7 plus 4 plus 3 plus 8 plus 5 plus 4. And I get a total of 50. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My mean is 5. Now I need to figure out how far each number is from 5. So 1, 2, 2, 0, 2, 1, 2, 3, 0, and 1. Those are all the distances from 5. So I'm going to add all those together. I'm just adding those right now. And I get a total of 14. And again, I divide by 10. So my MAD is 1.4 for 8, machine A. Machine B, I'm going to find the mean first. So I'm adding my numbers together. Ooh, I get another total of 50. So the mean for the second data set is also 5. But now I'm going to see how far is each number from that mean. So this is 1 away, 0, 1, 1, 0, 1, 0, 1, 1, 0. So I'm going to add all of these together. And I get a total of 6. And the MAD for this data set is 0.6. So what can we conclude? Well, the MAD for machine A is greater than the MAD for machine B. Therefore, machine A has a greater spread of data, which just means that their data values are farther from the mean than machine B. Okay, again, a higher MAD indicates that the data points are more spread out from the mean. So that was what you can conclude. So before you leave, make sure you can interpret the mean absolute deviation of a data set, and thanks for watching.